There's something deeply humbling about looking up at the night sky and realizing just how much we don't know. Out there, beyond the familiar constellations and the glow of our own Milky Way, lies a universe teeming with mysteries that challenge everything we think we understand. And few places embody that mystery more strikingly than the galaxy known as NGC 1277. Nestled 220 million light-years away, this ancient cosmic island is a relic from the early universe, a place where the rules of physics seem to twist into something stranger, something almost otherworldly. Imagine a galaxy so peculiar that it defies the very foundations of what we know about how galaxies form and evolve. NGC 1277 isn't just unusual, it's a cosmic anomaly, a place where strange objects lurk in the shadows, objects so baffling that astronomers still struggle to explain them. Some of these enigmas appear to be remnants of a violent past, while others seem to defy classification entirely. They don't fit neatly into any category, leaving scientists scratching their heads and rewriting theories. And today, we're going on a journey to uncover 30 of the most bizarre, mind-bending objects hidden within this galactic oddity. What makes these discoveries so thrilling isn't just their strangeness, it's what they tell us about the universe itself. Every unexplained object in NGC 1277 is a clue, a piece of a puzzle that could reshape our understanding of cosmic history. Are these remnants of ancient collisions? The fingerprints of unseen forces, or something even more extraordinary? The answers might be waiting in the data, hidden in the faint whispers of light that have traveled across millions of years just to reach us. So buckle up, because by the end of this voyage, you won't just see the cosmos differently, you'll feel it differently too. Right at the heart of NGC 1277, something impossible looms, an anomaly so massive it shouldn't exist. The galaxy's supermassive black hole isn't just a gravitational titan, it's a cosmic rule breaker, clocking in at a staggering 17 billion times the mass of our Sun. It dwarfs the black holes we'd expect to find in a galaxy this small. To put that into perspective, our own Milky Way's central black hole, Sagittarius A, seems almost modest by comparison, weighing in at just 4 million solar masses. But here's the thing, galaxies and their black holes usually grow in lockstep like cosmic partners. The larger the galaxy, the larger its central black hole. That's what decades of observations have told us, yet NGC 1277 flips that logic on its head. This isn't just a slight discrepancy, it's a glaring mismatch. How could a relatively compact galaxy, one that stopped forming stars billions of years ago, harbor a black hole of such monstrous proportions? One theory suggests it might be a relic from a more chaotic era, a time when the early universe was a battleground of colliding galaxies and voracious black holes. Perhaps NGC 1277 black hole gorged itself during those violent early days, growing to an unprecedented size before its host galaxy had a chance to catch up. Then, for reasons we don't yet understand, the galaxy simply stopped evolving, freezing in time while its black hole remained as a fossil of that ancient frenzy. And the effects of this gravitational behemoth are just as unsettling. Stars near the galaxy's core don't orbit the way they should. Instead of following predictable, orderly paths, they whip around at dizzying speeds, their trajectories warped by the black hole's overwhelming pull. Some astronomers speculate that this extreme environment might even eject stars entirely, flinging them out into the void like cosmic slingshots. It's as if the black hole isn't just defying expectations, it's rewriting the rules of galactic behavior right before our eyes. What's truly mind-bending, though, is what this means for our understanding of black hole formation. If NGC 1277 outlier isn't alone, if other galaxies hide similarly mismatched monsters, then our textbooks might need more than a few revisions. Could there be an entire population of these overgrown black holes lurking in the universe, unnoticed until now? Or is this galaxy a genuine oddity, a cosmic fluke that forces us to rethink how black holes and galaxies co-evolve? Every new observation peels back another layer of the mystery, and with each revelation, NGC 1277 supermassive black hole becomes not just an anomaly, but a key to unlocking the universe's deepest secrets. While the supermassive black hole at NGC 1277 core defies expectations, the galaxy's stars tell an equally strange story, one written in faded red light. Unlike younger, bluer galaxies still buzzing with star formation, this cosmic relic glows with the dull embers of ancient suns, a population astronomers call red and dead. These aging stars dominate NGC 1277 so completely that the galaxy appears frozen in time, like a celestial museum piece from the universe's early chapters. What's baffling isn't just that star formation stopped here, it's how abruptly it happened. Most galaxies of this size gradually fade as they exhaust their gas, but NGC 1277 seems to have slammed the brakes. Evidence suggests its star-making factories shut down nearly 12 billion years ago, when the universe was less than 2 billion years old. That's like a vibrant city turning into a ghost town overnight, leaving behind only echoes of its former vitality. The mystery deepens when we compare it to other galaxies from the same era. Even ancient galaxies usually show some trace of later activity, mergers that reignited star birth or pockets of late-forming stars. But NGC 1277 stellar census reveals no such second act. Its stars are nearly all the same age, as if some cosmic event sterilized the galaxy in one swift blow. One leading theory points to its monstrous black hole. Perhaps the energy unleashed by its feeding frenzy blasted away the gas needed to form new stars, starving the galaxy into dormancy. Yet that explanation raises new questions. Why didn't other galaxies with comparable black holes suffer the same fate? And how did NGC 1277 avoid the gravitational tug of war that typically disrupts such isolation over billions of years? Its red stars aren't just relics, they're witnesses to a history we're only beginning to decode. Every spectrum taken from their faint light carries clues about the forces that pressed pause on this galaxy's evolution, leaving it suspended between eras like a fossil trapped in amber. For astronomers, this red and dead population is more than a curiosity, it's a challenge to our models of galactic life cycles. If NGC 1277 represents a forgotten chapter in cosmic history, how many other galaxies followed this same strange path, and what does that mean for our understanding of how the universe grows old? The answers might rewrite not just the story of one peculiar galaxy, but the entire timeline of galactic evolution. If there's one thing astronomers thought they knew about galaxies, it's that dark matter holds them together. This invisible, mysterious substance is supposed to be the cosmic scaffolding, the hidden glue that keeps stars from flying apart. Yet NGC 1277 has thrown that assumption into chaos. Unlike nearly every other galaxy we've observed, this one seems to be missing its dark matter entirely, or at least it's hiding it so well we can't detect it. That's like finding a skyscraper without a foundation, standing tall against all logic. The evidence comes from the way stars move within the galaxy. In most systems, stars orbit faster than they should based on the visible matter alone, a telltale sign that dark matter's gravitational pull is at work. But in NGC 1277, the star's motions match what we'd expect if only the visible matter, stars, gas, and that monstrous black hole were present. No extra pull, no invisible influence. It's as if the universe forgot to include the ingredient that makes up 85% of a typical galaxy's mass. This revelation has sparked fierce debate among scientists. Some argue that dark matter might have been stripped away long ago, perhaps during a violent encounter with another galaxy. Others suggest the black hole's extreme gravity could have disrupted the dark matter halo, scattering it beyond detection. Then there's the most radical possibility, that NGC 1277 formed in a way that bypassed dark matter entirely, challenging our fundamental models of how galaxies are born. The implications ripple far beyond this one galaxy. If dark matter isn't always the anchor we thought it was, what does that mean for our understanding of cosmic structure? Could there be entire populations of galaxies that defy this rule, lurking unnoticed in the cosmic shadows? Or is NGC 1277 a rare exception, a cosmic accident that forces us to question just how universal our theories really are? Every observation adds another twist to the mystery, proving that even the most basic assumptions about the universe are still up for debate. Among the many oddities swirling around NGC 1277, there's one group of cosmic escape artists that stands out: its rogue globular clusters. These dense, ancient star clusters, usually the serene elders of a galaxy, are moving so fast they seem to be fleeing for their lives. While most globular clusters orbit their host galaxies at predictable, stately speeds, NGC 1277 are racing away like they've been catapulted by some unseen force. Their velocities are so extreme that many have already crossed the point of no return, destined to drift forever into the void between galaxies, the strangest part. Globular clusters aren't lightweight objects. Each one packs hundreds of thousands of stars into a tight sphere, making them among the most massive structures in a galaxy. For something that hefty to be hurled outward at such speeds, the force behind it must have been unimaginably violent. One leading suspect is, unsurprisingly, the galaxy's supermassive black hole. When black holes of that size interact with passing objects, they don't just nudge them, they can slingshot them into deep space with gravitational kicks powerful enough to overcome the galaxy's pull. But there's another possibility, a long-ago galactic collision. If NGC 1277 once had a catastrophic encounter with another galaxy, the gravitational chaos could have sent these clusters spiraling outward like billiard balls struck by a cue. Some might have been flung directly, while others could have gotten trapped in a gravitational tug of war between the two galaxies, eventually losing the battle and being ejected entirely. What makes these runaway clusters more than just a curiosity is what they reveal about the galaxy's hidden past. Normally, globular clusters are galactic historians holding clues about a galaxy's formation. But in NGC 1277, the ones that remain might tell only half the story. The ones that escaped could have carried away vital evidence. Were they ripped from the galaxy's outskirts, or did they originate near the turbulent core, launched into exile by the black hole's fury? The answers could rewrite how we understand not just this galaxy, but the violent processes that shape all galaxies over time. Astronomers are now racing to track these fleeing clusters, hoping their trajectories will act like cosmic breadcrumbs leading back to the event that set them loose. If they can trace their paths, they might uncover a hidden chapter in NGC 1277 history, one filled with collisions, near misses, or eruptions of energy we've yet to imagine. Until then, these rogue clusters remain both a puzzle and a promise, proof that even the quietest-looking galaxies can hide storms beneath the surface. Deep within NGC 1277 sea of ancient red stars, astronomers have stumbled upon something even more archaic, a scattered population of stars so chemically primitive they seem frozen in the universe's infancy. These metal-poor stars, containing barely a trace of elements heavier than hydrogen and helium, are cosmic fossils dating back to a time before planets, before life, even before most of the elements in our bodies existed. Finding such relics isn't unusual in itself. They're common in the outskirts of large galaxies like our Milky Way. But in NGC 1277, they're hiding in plain sight, right in the galaxy's crowded core where they have no business being. The puzzle lies in how these stars survived the galaxy's supposed history. Heavy elements, what astronomers call metals, are forged in stellar explosions and spread through galaxies by successive generations of stars. Over billions of years, even the oldest stars usually get polluted with traces of these metals as they orbit through enriched environments. Yet NGC 1277 metal-poor stars remain pristine, as if they've been sequestered from the galaxy's turbulent life. One theory suggests they might have formed in a pocket of primordial gas that somehow avoided contamination, a rare bubble of the early universe preserved like a time capsule. But the plot thickens when you consider where these stars are located. Metal-poor stars typically linger in galactic halos, the sparse outer regions where ancient stellar populations drift undisturbed. NGC 1277 outliers, however, are mingling with metal-rich stars near the galaxy's chaotic center, a place where supernova and black hole activity should have peppered everything with heavy elements. It's like finding cave paintings in the middle of a modern city, untouched by time. Some researchers speculate these stars might have been kidnapped, captured from a smaller, more primitive galaxy during a long-ago collision. Others wonder if NGC 1277 early shutdown in star formation left pockets of unprocessed gas that somehow collapsed into stars much later against all odds. The implications stretch far beyond this one galaxy. If metal-poor stars can persist in such unexpected places, it could mean our understanding of galactic chemical evolution is missing a critical piece. Perhaps there are mechanisms that shield certain stellar populations from enrichment, or maybe early galaxies had wildly uneven distribution of metals that we're only now beginning to recognize. Each of these celestial relics is a silent witness to the universe's first chapters, and decoding their survival in NGC 1277 could rewrite the story of how galaxies and the elements within them grow and change. As telescopes peer deeper into this galactic oddity, one thing becomes clear: the past isn't just hiding in the distant cosmos. It's tucked away in plain sight, waiting to shake the foundations of what we think we know. NGC 1277 presents us with a cosmic contradiction, a galaxy that looks deceptively simple at first glance, yet hides layers of violent history in its very structure. While its smooth, lens-like shape classifies it as a lenticular galaxy, astronomers have spotted something astonishing buried within its glow, the ghostly remnants of a spiral arm. This fractured, asymmetrical swirl of stars and gas shouldn't exist in a galaxy like this, where rotation and time typically erase such delicate features. It's as if we're seeing a cosmic crime scene, with the evidence frozen mid-action, a spiral arm caught in the act of being torn apart. The presence of this disrupted arm points to a cataclysmic event in NGC 1277 past, most likely a collision or close encounter with another galaxy. When galaxies interact, their gravitational forces don't just pull, they warp, stretch, and distort. Picture two dancers spinning too close, their arms tangling before one is flung away. In this case, the encounter may have been so violent it triggered the spiral structure we see, only to leave it mangled when the other galaxy moved on. The arm's frayed edges and chaotic star motions suggest the damage wasn't recent. This was no glancing blow, but a full-scale gravitational assault that reshaped NGC 1277's destiny. What's fascinating is how much this single feature reveals about the galaxy's timeline. Spiral arms are ephemeral in nature, typically fading within a few 100 million years unless replenished by new star formation or external disturbances. The fact that NGC 1277 arm remnants persist tells us two things. First, that the disruptive event happened relatively recently in cosmic terms, and second, that the galaxy's dormant state, its red and dead shutdown, must have followed soon after. It's almost as if the collision not only twisted the galaxy's shape but also robbed it of the gas needed to heal, leaving the arm as a scar that never fully faded. This discovery also challenges assumptions about lenticular galaxies like NGC 1277. Astronomers once thought their smooth, intermediate forms were purely the result of aging spirals that ran out of gas and settled into quiet retirement. But the presence of this mangled arm suggests a more turbulent origin. Could some lenticular galaxies actually be the product of violent mergers, their spiral features not faded but shredded? If so, NGC 1277 might represent a snapshot of a pivotal moment in galactic evolution, caught between two states. The implications ripple outward. If mergers played a role in shaping NGC 1277's strange properties, its oversized black hole, its missing dark matter, even its rogue globular clusters, then this disrupted arm might be the thread tying all those mysteries together. Every warp in its structure, every stray star cluster, could be part of a larger story about how galaxies transform under extreme conditions. And with each new observation, we're not just piecing together the history of one peculiar galaxy. We're uncovering the hidden forces that shape the universe itself. Hovering just beyond the visible boundaries of NGC 1277, a spectral presence lingers. A vast, diffuse cloud of hydrogen gas so faint it emits no starlight, no glow, nothing but the faintest whisper of radio waves. This ghostly structure, detected only by the most sensitive telescopes, defies easy explanation. Hydrogen clouds aren't uncommon in the universe, but this one's sheer size and isolated position raise baffling questions. Stretching across thousands of light years, it drifts like cosmic fog, untethered to any obvious source. Is it the mangled remains of a smaller galaxy torn apart by NGC 1277 gravity? Or could it be primordial material, a wisp of the early universe that somehow avoided being swallowed by galaxies altogether? The cloud's motion offers tantalizing clues. Unlike the frenetic orbits of stars within NGC 1277, this hydrogen drifts at an oddly sedate pace, as if it's barely interacting with the galaxy at all. That's unexpected. If it were debris from a recent galactic collision, it should show signs of gravitational disturbance, its gas stretched into streams or heated by friction. Instead, it seems eerily pristine, almost untouched. Some researchers propose it might be falling in for the first time, a latecomer to the galactic party after billions of years adrift in intergalactic space. If so, it could represent a rare snapshot of how galaxies accrete fresh material, a process usually too slow and diffuse for us to witness, but there's a darker possibility. The cloud's shape, ragged at the edges, with dense knots woven through its structure, matches simulations of galaxies shredded by tidal forces. NGC 1277 supermassive black hole could have torn a passing dwarf galaxy apart, scattering its gas into this haunting formation. The black hole's gravity would have acted like a cosmic blender, stripping stars away while leaving behind this skeletal cloud as the only evidence of the carnage. If true, the hydrogen's quiet demeanor today masks a violent past, a silent witness to a gravitational massacre billions of years in the making. What makes this cloud particularly intriguing is its potential to unlock secrets about galactic diets. Galaxies grow by consuming smaller neighbors, but the details of how they digest or fail to digest their prey remain murky. This ghostly structure could be the galactic equivalent of a half-eaten meal, offering a rare chance to study the mechanics of cosmic predation in action. Are we seeing the lingering traces of a single catastrophic feast, Or is this the accumulated debris of multiple, smaller nibbles over eons? The answers could reshape our understanding of how galaxies evolve, not just in peculiar systems like NGC 1277, but across the universe. As telescopes probe deeper, the cloud's chemistry might hold the key. Primordial hydrogen would carry a distinct signature, nearly pure, uncontaminated by heavier elements forged in stars. But if it's the wreckage of a devoured galaxy, even trace amounts of oxygen, carbon, or nitrogen could betray its origins. Every new observation peels back another layer, turning this faint cosmic spectre into a Rosetta Stone for decoding the hidden interactions that shape galaxies. And in a universe where so much of the action happens in darkness, these whispers of hydrogen might just be the clearest voice we have. Every galaxy we know has entourages, swarms of smaller satellite galaxies orbiting like celestial moths around a brighter flame. The Milky Way has the Large and Small Magellanic Clouds. Andromeda boasts dozens of known companions. Even isolated galaxies tend to have at least a few faint dwarfs in their gravitational grip. But NGC 1277 stands utterly alone, a cosmic hermit floating in a void where satellites should be. This absence isn't just unusual, it's statistically bizarre, like finding a single tree in the middle of an empty forest with no saplings in sight. The oddity becomes even starker when we consider NGC 1277 history. Galaxies of its size and age typically accumulate companions over billions of years, either by capturing wandering dwarfs or nurturing them from leftover material. Yet deep searches around this galaxy reveal nothing but empty space. No faint smudges of light, no telltale star streams from disrupted satellites, just an eerie stillness. This flies in the face of dark matter theory, which predicts that galaxies should be nestled within vast halos of unseen material capable of anchoring smaller neighbors. If NGC 1277 has dark matter at all, why hasn't it collected the usual entourage? One compelling theory suggests a past so violent it stripped away every potential companion. Imagine NGC 1277 barreling through a dense galaxy cluster in its youth, where gravitational tides from larger neighbors could have ripped away its satellites like planets flung from a rogue star. Alternatively, its supermassive black hole might have played a role. Outbursts of energy during feeding frenzies could have heated near by gas so intensely that dwarf galaxies couldn't form in the first place. Yet another possibility is even more radical, that NGC 1277 never had satellites to begin with. Some simulations suggest that certain rare regions of the early universe might have had such smooth, undistributed material that dwarf galaxies simply didn't form around emerging giants. If true, this galaxy could be a time capsule from an alternate cosmic pathway, one where the usual rules of galactic growth didn't apply. The implications ripple far beyond this solitary galaxy. If NGC 1277 isolation isn't a fluke but a clue, it could mean our models of galaxy formation are missing entire chapters. Are there other only child galaxies lurking in the shadows, overlooked because we assumed they'd follow the crowd? Or does this lonely giant hint at a deeper truth that the universe allows for more diverse evolutionary paths than we ever imagined? Every empty patch of sky around NGC 1277 isn't just absence. It's a question written in negative space, waiting for an answer. Hidden among the faint specks of light surrounding NGC 1277, astronomers spotted what appeared to be just another ultra-compact dwarf galaxy, a common, if peculiar, class of objects. These UCDs are essentially the cosmic equivalent of overpacked suitcases, cramming millions of stars into a space smaller than most star clusters. But as researchers trained their telescopes closer, this particular object didn't just break the mold, it shattered it entirely. Instead of the expected dense ball of stars, they found something unprecedented, a bizarre, bloated core with almost no stars at all, yet emitting enough radio waves to rival an entire galaxy. The first clue that this was no ordinary UCD came from its light profile. Typical ultra-compact dwarfs show a smooth distribution of starlight, brightest at the center and fading outward. This imposter had a jagged, uneven glow with strange gaps and bright knots that made no sense for a gravitationally bound system. Even more puzzling was its movement. While most UCDs orbit predictably around their host galaxies, this object seemed to be on a chaotic, almost drunken path, as if it had been flung into space by some tremendous force. Then came the radio emissions. UCDs are usually radio quiet, but this object blazed with signals typically associated with active galactic nuclei or supermassive black holes. Yet follow-up observations revealed no black hole, no accretion disk, nothing that could explain the energy output. Instead, the emissions pulsed erratically like a malfunctioning beacon. One theory suggests it might be the stripped core of a once larger galaxy, its outer stars ripped away by tidal forces, leaving behind a dense, magnetically active remnant. But that doesn't account for the sheer intensity of its radio signature or why similar objects haven't been found elsewhere, the most radical hypothesis. This might be a new class of object altogether, one that formed under conditions so rare or violent that we've never seen its like before. Perhaps it's the remnant of a near-miss collision between galaxies, where extreme gravitational forces warped a cluster of stars into something unrecognizable. Or maybe it's the visible echo of a long-dead quasar, its energy source gone but its magnetic field still whirling in the void. Whatever the case, this UCD imposter stands as a stark reminder that even the most familiar cosmic categories can hide extraordinary secrets. What makes this object especially tantalizing is what it implies about our ability to classify the universe's oddities. Astronomers rely on patterns grouping objects by shared traits to make sense of the cosmos. But NGC 1277 Phantom UCD refuses to fit, forcing us to question whether our categories are as rigid as we think. If this anomaly has counterparts elsewhere, lurking undetected because they don't match expected profiles, how many other cosmic mysteries are we overlooking? Sometimes the universe's most important lessons come not from the answers we find, but from the objects that defy every label we try to give them. Gravity is supposed to be predictable, mass bends space, and light follows the curve. That's why we can use galaxies like cosmic magnifying glasses, their immense gravity warping the light of objects behind them into arcs and rings. But when astronomers turned their instruments toward NGC 1277, the background galaxies didn't just bend. They twisted into shapes that defied every model, creating a gravitational funhouse mirror where the reflections made no sense. The distortion patterns suggest something unsettling about this galaxy's mass distribution. Normally, a galaxy's gravity lensing effect matches its visible structure. The heavier the core, the sharper the bend. NGC 1277 lensing, however, acts like its mass is unevenly smeared, with dense pockets lurking where no stars or gas can account for them. Some regions produce lensing effects twice as strong as expected, while others barely register. It's as if the galaxy's gravity is flickering in and out of focus, revealing hidden density variations that shouldn't exist in a system this old and quiet. One possible explanation ties back to the galaxy's missing dark matter. If dark matter normally smooths out a galaxy's gravitational field like an invisible buffer, its absence here might let the visible matter's clumpiness dominate, creating these erratic lensing hotspots. But that doesn't fully explain the scale of the anomalies. Some distortions imply concentrations of mass so dense they'd rival small black holes floating untethered in the galaxy's outskirts. Could these be the remnants of devoured dwarf galaxies, their cores left to orbit like unmoored anchors? Or is there an unseen component interacting with gravity in ways we've never observed? The most perplexing lensed image shows a background galaxy stretched into a perfect crosshair shape, a configuration so rare it's been observed only a handful of times in the universe. Simulations suggest this requires an almost impossibly precise alignment between foreground and background objects, with the lensing galaxy's mass distributed in a highly asymmetrical way. For NGC 1277 to produce this effect, its mass couldn't just be lopsided, it'd need to be arranged in a jagged, almost artificial-seeming configuration, like a series of invisible walls slicing through space. What makes these distortions more than a curiosity is what they imply about our understanding of gravity itself. Einstein's theory has passed every test we've thrown at it, but NGC 1277 lensing anomalies push it to the brink. Either we're missing a fundamental piece of how mass behaves in extreme environments, or this galaxy is hiding something that warps spacetime in a way we can't yet explain. Every distorted background galaxy is more than a fluke. It's a clue, a ripple in the fabric of reality pointing toward physics we've yet to discover. One of the most bewildering contradictions in NGC 1277 lies in what we don't hear, the deafening radio silence from a black hole that should be shouting across the cosmos. Supermassive black holes, especially ones as oversized as this galaxy's 17 billion solar mass behemoth, are typically anything but quiet. As they devour surrounding matter, they belch out torrents of radio waves, creating brilliant jets and lobes visible across millions of light years. Yet NGC 1277 black hole sits in near-perfect stillness, emitting less radio noise than some backyard satellites. It's like finding a roaring waterfall frozen mid-cascade, defying every expectation of how black holes behave. This anomaly becomes even starker when compared to other galaxies with similar black holes. Take Messier 87, home to the first black hole ever imaged. Its jets stretch for thousands of light years, pumping out radio emissions so intense they outshine entire galaxies. Even quieter black holes, like the one in our own Milky Way, still flicker with intermittent radio bursts as they snack on passing gas clouds. But NGC 1277 Titan is practically mute, raising an obvious question. What silenced it? The answer might lie in the galaxy's extreme isolation. Black holes need fuel to roar, usually supplied by a steady diet of gas, stars, or even other black holes. Yet NGC 1277 is a near-perfect cosmic desert. Its star formation died eons ago, and there's little evidence of recent mergers that could have delivered fresh material. Without a consistent influx of matter, the black hole may have entered a state of starvation so severe it can't even muster a whisper. But starvation alone doesn't explain everything. Some dormant black holes still produce faint radio emissions from their lingering magnetic fields or the occasional stray particle. NGC 1277 silence is almost too absolute. Another possibility is that the black hole's own violence sealed its fate. In its youth, it might have unleashed such ferocious outbursts that it blasted away not just its gas reserves but the very mechanisms needed to produce radio emissions. Imagine a forest fire so intense it burns away all the oxygen, choking itself out. If the black hole's past activity disrupted the magnetic fields that usually accelerate particles into radio-emitting jets, it could have left behind a bizarrely inert remnant, a sleeping giant with no way to wake. Or perhaps the silence is an illusion. Some theorists speculate that the radio waves might be there, just pointed in the wrong direction. Active black holes often emit energy in tight beams like cosmic lighthouses. If NGC 1277 jets are aimed directly away from us, we might be missing the show entirely. But even this explanation feels unsatisfying, as it doesn't account for the lack of diffuse radio halos typically seen around such beamed systems. What makes this radio silence so consequential isn't just the puzzle itself. It's what it reveals about black hole life cycles. If NGC 1277 black hole truly is a dormant relic, it challenges the assumption that supermassive black holes always leave behind detectable traces of their activity. Could there be an entire population of these silent giants lurking in other galaxies, invisible to our radio telescopes, and if so, how many have we overlooked? The implications ripple through cosmology, potentially altering our census of black holes and redefining what active really means. For now, NGC 1277 Quiet Defiance remains one of its most profound mysteries. In a universe where black holes are often the loudest actors, this one's refusal to speak may be telling us something revolutionary, if only we could decipher its silence. Amidst the sea of ancient red stars that dominate NGC 1277, a splash of color stands out like a cosmic contradiction, a tight knot of brilliant blue stars burning hotter and younger than anything else in the galaxy. Dubbed the blue blob by astronomers, this cluster is an enigma wrapped in starlight. In a galaxy where star formation supposedly ended 12 billion years ago, these stars shine with the vigor of youth, their blue-white light betraying ages measured in mere millions of years. It's as if a bustling neon city square appeared in the middle of an archaeological ruin, defying every expectation of what this fossil galaxy should contain. The existence of these stars raises an obvious question. How did they form in a place long thought devoid of the raw materials needed to birth new suns? Star formation requires cold, dense gas, the very resource NGC 1277 exhausted eons ago. One theory suggests a galactic heist. Perhaps this cluster wasn't born here at all but stolen. If a wandering gas-rich dwarf galaxy strayed too close, NGC 1277 gravity could have torn it apart, funneling its remaining gas into a tight pocket near the core. Under the right conditions, that gas might have collapsed into the blue blob stars, a final spark of creation in an otherwise dormant system. But there's a twist. The chemistry of these stars doesn't quite match the typical profile of captured material. Their atmospheres contain unexpected traces of heavier elements, hinting at a more nuanced origin. Some researchers propose that NGC 1277 might harbor hidden reservoirs of gas, pockets so well shielded by magnetic fields or turbulence that they survived the galaxy's early quenching. Occasionally, these pockets could collapse under their own weight, igniting brief, localized bursts of star formation. If true, it would mean the galaxy isn't quite as dead as we thought, just extraordinarily selective about where and when it creates new stars. The blue blob's location deepens the mystery. Instead of lingering in the galaxy's outskirts where fresh gas might accumulate, it's nestled uncomfortably close to the supermassive black hole, a region where gravitational forces should tear apart any forming stellar nurseries. Yet here it thrives, its stars orbiting at velocities that suggest they're somehow immune to the chaos around them. This resilience has led to a radical idea. Perhaps the black hole itself played midwife to these stars. In rare cases, the intense pressure waves from black hole activity can compress nearby gas clouds rather than dispersing them, triggering star birth in the most hostile environments imaginable. What makes the blue blob more than a curiosity is what it implies about galactic life cycles. If stars can form in places and ways we didn't predict, then our models of galaxy evolution might be missing entire chapters. Other red and dead galaxies could hide similar surprises, their quiet exteriors masking fleeting moments of rebirth. Or perhaps NGC 1277 blue anomaly is a cosmic fluke, a reminder that the universe always reserves the right to break its own rules. Either way, this cluster of young rebels challenges us to rethink not just one galaxy's history, but the very definition of stellar extinction and renewal. Buried deep within the data from NGC 1277 core, an X-ray signal pulses with unnatural persistence, a beacon of high-energy light that shouldn't exist. This mysterious source flickers like a cosmic strobe, emitting bursts of radiation so intense they briefly outshine the entire galaxy in X-rays. Yet when astronomers train optical telescopes on its coordinates, they find nothing. No visible object, no glowing gas cloud, not even a stray star. It's as if the universe has conjured an invisible furnace, pumping out enough energy to power a quasar while leaving no trace of its origin. Theories about what's causing this X-ray enigma split into two camps. The first points to a hidden black hole, one far smaller than the galaxy's central supermassive beast but no less ravenous. Intermediate mass black holes, those elusive cosmic middleweights between stellar remnants and galactic titans, could produce exactly this kind of intermittent, high-energy flare as they rip apart passing stars. If one lurks in NGC 1277 outskirts, it might have escaped detection until now simply because it spent millennia dormant, only recently awakening to devour an unlucky asteroid or white dwarf. But there's a wrinkle. The signal's irregular rhythm defies typical black hole feeding patterns. Instead of the steady pulse of matter spiraling inward, this source crackles unpredictably, flaring for days before vanishing for months. That erratic behavior aligns better with a neutron star specifically, a magnetar, the most magnetic object in the universe. These ultra-dense stellar corpses can unleash bursts of X-rays when their crusts fracture under unimaginable magnetic strain. Yet even that explanation falls short, as no known magnetar produces flares this powerful at such vast distances, which leads to the third, more unsettling possibility, something entirely new. Some exotic stellar remnant, perhaps a quark star or black hole neutron star hybrid, could be pumping out radiation through physics we've yet to describe. Or the signal might not originate from a single object at all, but from the collision of two ultra-dense bodies in a long-ago merger, their final death scream echoing across the cosmos as delayed X-ray afterglow. The implications stretch far beyond NGC 1277. If this source represents a new class of object, it could rewrite our understanding of compact stellar evolution. If it's an intermediate black hole, it might reveal a hidden population threading through galaxies like invisible spiders. Every flicker from this X-ray phantom carries clues, not just about one galaxy's secrets, but about the universe's most extreme and enigmatic phenomena. Until we pin it down, it remains both a puzzle and a promise, proof that even in the quietest corners of space, the cosmos still has surprises up its sleeve. Stretching far beyond NGC 1277 main body, a gossamer ribbon of stars drifts through the void like a cosmic scar, a silent witness to a violent feast that occurred billions of years ago. This tidal stream, a delicate arc of stellar debris, tells the story of galactic cannibalism on an epic scale. Unlike the orderly orbits of stars within the galaxy, these exiled suns trace chaotic paths, flung outward by gravitational forces so intense they were ripped from their original home. The presence of such a stream isn't just evidence of a past collision. It's a forensic snapshot of the moment NGC 1277 tore another galaxy apart. Reconstructing this ancient cataclysm is like piecing together a crime scene from faint fingerprints. The stream's curvature suggests the victim wasn't just any galaxy, but one rich in gas and stars, possibly a dwarf spiral. As it ventured too close, NGC 1277 gravity stretched it like taffy, pulling stars into long, looping tendrils while its gas was siphoned away, either devoured by the black hole or blasted into intergalactic space. The most revealing clue lies in the stream's chemistry. Certain metal-rich stars clustered along its length hint that the devoured galaxy was still actively forming stars when it met its demise, cut down in its prime. But the real mystery isn't just what happened, it's how it happened so cleanly. Galactic mergers usually leave behind messy wreckage, distorted spiral arms, bursts of new star formation, or even glowing rings of shocked gas. NGC 1277 tidal stream, by contrast, is eerily pristine, its stars too smoothly distributed for a typical collision. One explanation is that the devoured galaxy was already dying when it was consumed, its gas reserves exhausted long before the final encounter. Without fresh gas to ignite fireworks of new star formation, the merger left only this faint stellar ribbon as a receipt of its meal. The stream's trajectory adds another layer of intrigue. Unlike the chaotic orbits of NGC 1277 rogue globular clusters, these stars move with a strange coherence, as if they're still trying to remember their original orbit. Some researchers believe this means the collision happened much more recently than the galaxy's other violent events, perhaps within the last few billion years. If so, it challenges the assumption that NGC 1277 has been dormant since the early universe. Maybe this galaxy isn't a fossil after all, but a slow, methodical predator biding its time between meals. What makes this tidal stream especially fascinating is what it implies about dark matter, or rather, the lack of it. Streams like this are usually shaped as much by the invisible halo of dark matter surrounding a galaxy as by its visible stars. Yet the curvature of this one suggests NGC 1277 gravitational influence drops off sharply at the edges, as if its dark matter halo is stunted or missing entirely. Could the original collision have stripped away not just stars, but the very scaffolding that holds galaxies together? Or is this stream evidence of a darker truth, that NGC 1277 never had much dark matter to begin with? Every star in that ribbon is a data point, a whisper from a long-dead galaxy. By mapping their motions and compositions, astronomers are essentially running the cosmic film backward, frame by frame, to glimpse the moment of destruction. And with each new observation, the story grows richer. Perhaps the devoured galaxy wasn't alone, maybe it had companions, and this stream is just the most visible remnant of a larger feast. Or perhaps the collision triggered NGC 1277 abrupt shutdown in star formation, making this tidal stream both a monument to destruction and the catalyst for stillness. In the end, this delicate strand of stars is more than debris. It's a testament to the fact that even the quietest galaxies wear the scars of their past, written in starlight for those who know how to look. And if we can decode its secrets, we might just uncover a universal truth, that cannibalism isn't the exception in the cosmos, it's the rule. Deep within NGC 1277 ancient stellar population, one star burns with an impossible intensity, a red giant so luminous it defies every model of stellar aging. This cosmic outlier, catalogued only as Object 15, radiates nearly twice the brightness predicted for stars of its size and composition, as if someone turned up a dial on its nuclear furnace. Red giants are supposed to be predictable aging stars in their final act, expanding and cooling as they exhaust their fuel. But this one behaves like a rebellious actor refusing to follow the script, shining with a vigor that demands an explanation. The anomaly becomes even stranger when we examine the star's composition. Unlike typical red giants enriched with heavier elements from a lifetime of fusion, Object 15's outer layers show a startling deficit of elements like lithium and beryllium. These missing ingredients suggest something disrupted the star's natural evolution, either accelerating its aging process or triggering an unnatural energy surge. One possibility is that it's not a single star at all, but the product of a stellar merger, two smaller stars colliding and combining their mass into one oversized giant. Such violent reunions can produce temporary luminosity spikes as the merged star struggles to find equilibrium, like a fire flaring up when fresh logs are tossed onto the embers. Yet there's a flaw in that theory. merged stars usually show distinct chemical fingerprints over abundances of carbon or nitrogen from the mixing of their inner layers. Object 15 lacks those telltale signs, leaving astronomers to consider even more exotic explanations. Could it have ingested a close-orbiting planet or brown dwarf, the added mass stoking its core to unnatural brilliance? Or is this a case of missing physics, some overlooked stellar process that allows certain red giants to burn far more efficiently than our models account for? The most tantalizing clue comes from the star's location, hovering perilously close to NGC 1277 supermassive black hole. Intense gravitational tides from the black hole could theoretically distort a star's internal structure, altering how heat circulates from core to surface. Picture a candle flame in a wind tunnel. The same fuel burns hotter and brighter when stretched and compressed by external forces. If true, this red giant might be the first documented case of tidal heating on a stellar scale, a phenomenon previously only theorized. What makes Object 15 more than a cosmic oddity is what it reveals about the limits of our knowledge. Stars like this shouldn't exist under current stellar evolution theories, yet here it shines defiantly bright. If it's a product of unique circumstances, a merger, a planetary meal, or black hole interactions, it challenges our understanding of how stars behave in extreme environments. But if it represents a gap in our physics, it could mean entire chapters of stellar life cycles remain unwritten. Every flicker from this too-bright giant is a beacon, illuminating not just the mysteries of one ancient galaxy, but the boundaries of what we think we know about the universe itself. At the fringes of NGC 1277, where the galaxy's ancient stars drift in predictable orbits, an invisible maelstrom rages, a vast disk of gas spinning defiantly backward, like a cosmic whirlpool flowing upstream. This counter-rotating gas cloud moves in perfect opposition to the galaxy's stellar dance, a phenomenon so rare it challenges our understanding of galactic mechanics. Normally, gas and stars align, born from the same primordial rotation. But here they wage a silent war, their opposing motions etching a hidden signature in radio telescope data. The origins of this rebellious disk point to a history of violence. One compelling explanation suggests it's the aftermath of a galactic theft. NGC 1277 may have stolen this gas from a passing dwarf galaxy orbiting in the opposite direction. When galaxies collide, their gas clouds don't instantly merge. They retain their original motion, creating swirling contradictions like this. Picture two whirlpools in a bathtub rotating in opposite directions. The water resists blending, maintaining its chaos long after the initial disturbance. Over billions of years, friction should have smoothed this imbalance, yet NGC 1277 counter-rotating disk persists, a fossilized record of an ancient heist. But there's another, more explosive possibility. The gas might be fallout from the supermassive black hole's past tantrums. Active black holes often eject jets of material at near light speeds, some of which can loop back and settle into retrograde orbits. If NGC 1277 black hole once spewed matter outward, some could have cooled and fallen back in the opposite direction, seeding this backward spinning reservoir. The disk's crisp, well-defined structure supports this idea. Its edges are too sharp for a gradual capture scenario, as if the gas was placed there deliberately rather than accumulating over time. What makes this disk more than a curiosity is what it reveals about the galaxy's evolution. Counter-rotation creates extreme turbulence, shredding molecular clouds before they can form stars. This could explain why NGC 1277 star formation died so abruptly. The backward spinning gas may have choked off its own fuel supply, turning the galaxy into a celestial desert. Even more intriguing, the disk's motion might be shielding it from the black hole's hunger. Gas moving against a black hole's spin has a harder time crossing the event horizon, like swimming upstream against a current. This could mean the disk is slowly starving the behemoth at the galaxy's core, locking away its last reserves of fuel in a gravitational stalemate. For astronomers, every molecule in this backward whirlpool is a time capsule. The gas's chemical composition laced with heavier elements like oxygen and carbon hints that it didn't originate in the primordial universe but was forged in later stellar generations. Somewhere along the way, NGC 1277 didn't just steal gas, it stole the ashes of dead stars, repurposing them into this swirling anomaly. And as researchers map its motions in finer detail, they might uncover something even more startling, evidence that the galaxy's turbulent past isn't over. The disk's outer fringes show faint ripples as if something, perhaps a dark matter substructure or the ghost of another collision, is still tugging at it, rewriting its story even now. Among the most perplexing discoveries within NGC 1277 is a gravitational phantom, an object that bends light like a dense star cluster but emits no starlight, no infrared glow, not even the faintest whisper across the electromagnetic spectrum. Catalogued as Object 17, this invisible cluster reveals its presence only through its gravitational pull, warping the paths of nearby stars as if an unseen hand were tugging at the fabric of space itself. It's the cosmic equivalent of feeling a gust of wind in an airtight room. Something massive is there, but nothing meets the eye. Theories about what this ghostly structure might be split into two camps. The first suggests it's a conventional star cluster shrouded in an unprecedented veil of dust. Normally, dust clouds scatter visible light but allow infrared radiation to pass through, revealing the stars within. Yet even the most sensitive infrared telescopes detect nothing, meaning if dust is the culprit, it would have to be colder and denser than any known in the universe, forming a perfect cosmic cloak. Some astronomers propose it could be fallout from a cataclysmic event, like the debris of a shattered planetesimal belt ground into ultra-fine particles over billions of years. But no known process creates dust so effective at hiding an entire cluster without a trace. The second, more radical possibility is that Object 17 isn't made of normal matter at all, but of dark matter condensed into an unprecedented structure. While dark matter is thought to form diffuse halos around galaxies, certain theories predict it could clump into dense knots under extreme conditions, like near NGC 1277 supermassive black hole. If true, this would be the first direct evidence of dark matter behaving in ways beyond our models, collapsing into objects that interact with gravity but nothing else. The cluster's gravitational fingerprint supports this idea. Its mass is concentrated in a way that mirrors visible globular clusters, but without any of the expected light-producing components. What makes this enigma especially tantalizing is its location, nestled within a stream of metal-poor stars that orbit NGC 1277 core. If the cluster is truly dark matter, its gravity could explain why these ancient stars remain so pristine, their orbits shielded from contamination by the invisible structure's pull. Alternatively, if it's a dust-shrouded relic, its presence might hint at a forgotten era when NGC 1277 was a factory for such extreme cosmic camouflage. Every scan of this ghostly object deepens the mystery. Radio telescopes have detected no synchrotron radiation, ruling out hidden pulsars or magnetars. X-ray surveys show no trace of heating from embedded black holes. Even gravitational microlensing, usually a reliable way to detect dark objects, fails to resolve its structure, as if the cluster is somehow evading scrutiny on purpose. The longer it resists explanation, the more it challenges our understanding of what matter, both seen and unseen, is capable of. Whether a cosmic illusion or a glimpse of physics beyond our grasp, Object 17 stands as a haunting reminder. The universe's greatest secrets might not hide in the light, but in the darkness between the stars. Amid the ancient stars of NGC 1277, one stands apart, not for its brightness or age, but for its sheer velocity. This rogue star, designated Object 18, rockets through space at over 2,000 kilometers per second, fast enough to cross the continental United States in less than a second. At that speed, it isn't just moving, it's escaping, tearing free from the galaxy's gravitational grip entirely. Stars like this, known as hypervelocity stars, are cosmic cannonballs, and their existence traces back to one of the universe's most violent processes, a close encounter with a supermassive black hole. The physics behind this stellar ejection are staggering. For a star to reach such velocities, it must have ventured perilously close to NGC 1277's central black hole, skimming the edge of its event horizon. Picture a slingshot spun to breaking point. The star wouldn't just be flung outward. It would be whipped into space by the black hole's unimaginable gravity, gaining speed like a pellet in a cosmic railgun. Calculations suggest the star was part of a binary system, orbiting a companion star until the black hole's tidal forces ripped them apart. One star was captured, spiraling into oblivion, while the other was hurled away, its trajectory forever altered by that brief, brutal interaction. What makes Object 18 particularly fascinating is its trajectory. Unlike most hypervelocity stars which shoot out in random directions, this one follows a path that points directly back to the galaxy's core, a smoking gun linking it to the black hole's fury. By tracing its route backward, astronomers have reconstructed the conditions of its ejection, revealing just how finely tuned the event must have been. Too close to the black hole and the star would have been shredded. Too far and it wouldn't have reached escape velocity. The precision required to produce such an outcome borders on the unreal, a reminder of how chaotic yet calculable the cosmos can be. The star's composition adds another layer of intrigue. Spectroscopic analysis shows it's a blue straggler, a type of star that appears younger and hotter than its surroundings. This suggests it might have been rejuvenated during its close brush with the black hole, either through tidal heating or by merging with its binary companion in the moments before their separation. Imagine a phoenix not rising from ashes but from a gravitational inferno, hotter and brighter for having survived the ordeal. But the implications stretch beyond this one star. If hypervelocity ejections are happening in NGC 1277, they're likely happening elsewhere too. Every escaping star carries with it a piece of its home galaxy's history, a clue about the black hole's activity and the dynamics of its surroundings. Some of these stars might even traverse intergalactic space, seeding the void with rogue luminaries that could one day pass through other galaxies, silent witnesses to the violence of their birth. Object 18's journey is more than a curiosity, it's a testament to the extremes of gravity and motion. As it streaks through the cosmos, it challenges us to rethink not just how stars move, but how galaxies shape their fates. In the grand tapestry of the universe, even the fastest star is a slow messenger, carrying secrets from a place where space and time bend to the will of something infinitely darker. NGC 1277 dust lanes weave through its ancient starlight like scars from a forgotten battle, twisting fractured ribbons of cosmic soot that defy the galaxy's otherwise orderly structure. Unlike the symmetrical dust spirals seen in younger galaxies, these lanes crisscross at odd angles, some even folding back on themselves in chaotic loops. It's as if someone took a knife to the galaxy's fabric, leaving behind gashes that never fully healed. For astronomers, these tangled filaments aren't just cosmetic flaws. They're forensic evidence holding clues about whether this galaxy's peculiarities stem from violent collisions or some internal meltdown we've yet to understand. The first clue lies in the dust's peculiar distribution. Most lenticular galaxies like NGC 1277 display dust concentrated along their equatorial plane, a relic of their star-forming days. But here, the dust is clumped in uneven patches, with some filaments stretching perpendicular to the galaxy's rotation, as if flung outward by an explosive force. One theory points to a long-ago merger, perhaps a smaller gas-rich galaxy plowed through NGC 1277 disk, its debris scattering like confetti in a cosmic storm. Supporting this idea are the dust lane's chemical fingerprints, traces of silicate and graphite grains laced with organic molecules, materials typically forged in the turbulent aftermath of galactic collisions. Yet there's a wrinkle. If a merger shaped these lanes, why haven't they settled into alignment over billions of years? Dynamic friction should have smoothed their paths long ago, unless something, maybe the supermassive black hole's gravity, is actively stirring them. Observations reveal the densest dust knots orbit unusually close to the black hole, where tidal forces stretch and compress them like cosmic taffy. This could explain the lane's frayed edges and knotted textures, as if they're caught in an endless tug of war between gravity and momentum. The most startling possibility, though, is that the dust isn't a relic at all but a symptom of ongoing chaos. Recent infrared data shows faint heat signatures in the lanes, suggesting some grains are being reheated, possibly by shockwaves from stellar collisions or black hole-driven winds. If confirmed, it would mean NGC 1277 isn't the dormant fossil we thought. Even in its apparent stillness, it might harbor pockets of turbulence like a dormant volcano venting steam. What makes these dust lanes more than a curiosity is what they imply about galactic resilience. If they're indeed remnants of a past merger, their persistence challenges assumptions about how quickly galaxies recover from collisions. But if they're evidence of internal instability, they could rewrite our understanding of how dead galaxies evolve, or refuse to. Every twist in these cosmic ribbons is a sentence in a story we're only beginning to read, a reminder that even the quietest corners of the universe seethe with hidden drama. Stretching across the cosmic canvas like a celestial shadow, a puzzling anomaly known as the cold spot lingers in the same patch of sky as NGC 1277, an eerie alignment that has astronomers questioning whether it's a fluke or a cosmic breadcrumb. Discovered in maps of the cosmic microwave background, the afterglow of the Big Bang, this region is noticeably colder than its surroundings, as if some unseen force siphoned away its energy. At first glance, it could be written off as a statistical oddity, a random fluctuation in the universe's oldest light. But the fact that it overlaps with NGC 1277 neighborhood hints at something far more profound. Could this galaxy be sitting at the epicenter of a cosmic defect, a wrinkle in spacetime itself? The cold spot isn't just a minor temperature dip. It spans nearly 1 billion light-years, a void so vast it challenges our understanding of how matter clumps together in the universe. One leading theory suggests it might be a supervoid, an underdense region where galaxies are scarce and gravity's pull has stretched spacetime, redshifting light and cooling the background radiation. Yet even this explanation falls short. Simulations show that a void large enough to create such a chill would need to be impossibly sparse, a near-perfect vacuum that defies the universe's usual lumpiness. NGC 1277, meanwhile, sits like a sentinel at the edge of this enigmatic zone, its own peculiarities mirroring the cold spot's defiance of cosmic norms. This coincidence has sparked a radical alternative, that the cold spot isn't a void at all, but evidence of a collision between our universe and another bubble of spacetime, a multiversal bruise. If true, the gravitational shockwaves from such an event could have left behind ripples in the fabric of reality, warping the cosmic microwave background and perhaps even influencing the formation of galaxies like NGC 1277. Its bizarre properties, the missing dark matter, the oversized black hole, the backward spinning gas, might not be isolated quirks, but downstream effects of a primordial cataclysm we're only beginning to detect. Or perhaps the link is more direct. Some theorists propose that NGC 1277 supermassive black hole, in its youth, unleashed energy so titanic it locally reheated spacetime, leaving behind a colder footprint in the cosmic microwave background. Imagine blowing on a hot cup of coffee. The spot where your breath hits cools momentarily, even as the rest stays warm. If black holes can alter the universe's thermal history on such scales, it would rewrite our models of how these monsters shape cosmic evolution. Yet for all the speculation, the cold spot remains a riddle wrapped in an enigma. Its sheer scale resists easy explanation, and its overlap with NGC 1277 territory could still be a trick of perspective, a chance alignment of two unrelated oddities. But in science, coincidences this stark are often clues in disguise. Whether it's a window into the multiverse, a fossil of black hole upheaval, or something entirely unforeseen, the cold spot forces us to confront a humbling truth. Even the universe's oldest light still holds secrets, and NGC 1277 might be the key to deciphering them. In the vast neighborhood surrounding NGC 1277, astronomers watched with fascination as a lone gas cloud performed the ultimate vanishing act. Initially detected in 2014, this swirling mass of hydrogen drifted perilously close to the Galaxies' supermassive black hole, its fate seemingly sealed. Conventional wisdom suggested it would be torn apart in a spectacular light show, stretched into luminous filaments as it spiraled toward oblivion. But the universe delights in defying expectations. Instead of a fiery demise, the cloud simply disappeared. Not with a bang, but with a whisper. The first signs of trouble came when radio telescopes monitoring the cloud's expected trajectory found nothing but empty space where dense gas should have been. Follow-up observations across multiple wavelengths confirmed the unthinkable. An entire structure spanning hundreds of astronomical units had evaporated without leaving the faintest trace. No X-ray flare marked its consumption by the black hole. No shockwaves rippled through nearby star-forming regions. It was as though the cosmos had erased a paragraph from its own story mid-sentence. Two competing theories emerged to explain this cosmic sleight of hand. The first posits that the black hole did, in fact, consume the cloud, just not in the way we anticipated. Rather than being shredded into observable streamers, the gas may have been funneled directly into the black hole's accretion disk with freakish efficiency, like water swirling down a drain with no splashes. Such quiet feeding events are rare but not impossible, especially if the cloud approached at just the right angle to avoid disrupting the disk's magnetic fields. The second, more unsettling possibility is that forces beyond our current understanding dismantled the cloud before it reached the black hole. NGC 1277 core emits faint but persistent jets, outflows of charged particles normally too weak to affect something as massive as the observed gas cloud. However, if these jets interacted with turbulent magnetic fields in just the right way, they could have ionized the hydrogen, breaking its molecular bonds and scattering its atoms into invisibility. Imagine a sandcastle hit not by a wave but by a sudden gust that transforms each grain into mist. What makes this disappearance more than a curiosity is the timing. The cloud vanished during an otherwise quiet phase in NGC 1277 history, ruling out obvious culprits like quasar outbursts or nearby supernova. Its silent exit hints at subtler mechanisms at work, processes we've yet to model or even name. Some astronomers speculate this could be our first glimpse of dark turbulence, hypothetical instabilities in the interstellar medium that operate on scales too fine for current telescopes to resolve. Others wonder if the cloud never existed as a coherent structure at all, but was instead a fleeting alignment of cosmic mirages, a trick of light and perspective. The paradox is this: the quieter the event, the louder its implications. If black holes can devour entire gas clouds without leaving forensic evidence, our census of their meals, and thus their growth, might be woefully incomplete. Conversely, if unseen forces can dismantle massive objects with such eerie precision, we may need to rethink how matter behaves in extreme gravitational environments. The ghost of that vanished cloud lingers in the data, a silent challenge to our cosmic confidence. Sometimes what the universe removes teaches us far more than what it leaves behind. Most galaxies hum with magnetic energy, their fields twisting and braiding like invisible rivers of force, but NGC 1277 magnetic field stands eerily still, locked in a state resembling cosmic frostbite. While typical galaxies show magnetic lines dancing with turbulence stretched by star formation, crumpled by supernova, or wound tight by black hole jets, this relic galaxy's field is almost unnaturally smooth, as if time forgot to touch it. It's the difference between a roaring rapid and a frozen waterfall, both made of water, but one pulses with motion while the other hangs in suspended animation. The stillness defies expectation. Magnetic fields in galaxies are typically dynamic, sustained by churning gas and stellar winds. Even in dead galaxies like NGC 1277, past activity usually leaves behind tangled magnetic remnants like scars from old battles. Yet here, the field lines run straight and undisturbed, showing no sign of the chaos that should accompany a galaxy with a history as violent as this one's. Radio observations reveal a startling uniformity, with field strength barely varying across thousands of light years, a stark contrast to the patchwork of highs and lows seen in similar galaxies. One explanation points to the galaxy's abrupt halt in star formation. Without newborn stars to pump energy into the interstellar medium, and without supernova to stir turbulence, the magnetic field may have simply frozen in place. Imagine turning off a blender mid-spin. The swirling liquid inside would gradually settle, losing its chaotic motion. In NGC 1277 case, that settling might have locked the magnetic field into its current state, preserving it like a bug in amber for billions of years. But there's a catch. Magnetic fields aren't supposed to last that long without decay. Left alone, they should dissipate over cosmic timescales, their energy leaching away into space. The fact that NGC 1277 field persists suggests something is propping it up, perhaps residual currents from its long-dead stars or subtle interactions with the supermassive black hole's faint jets. Alternatively, the field might not be primordial at all, but recently recharged by a slow leakage of energy from the galaxy's halo, like a dying battery trickling one last surge of power. The most tantalizing possibility is that we're witnessing a rare magnetic fossil, a snapshot of how fields behaved in the early universe, before turbulence and star birth complicated their structures. If so, studying this frozen field could reveal secrets about cosmic magnetism itself, how it arises, how it evolves, and whether it plays a hidden role in shaping galaxies. Magnetic fields are often overlooked in galactic evolution models, treated as secondary players. But NGC 1277 eerie stillness forces us to reconsider. Could magnetism, or the lack thereof, be the invisible hand behind some of this galaxy's other mysteries? For now, the frozen field remains a paradox, too orderly for a galaxy with such a violent past, yet too persistent for one that's been dormant so long. Whether it's a relic of lost physics, a quirk of isolation, or a clue to something deeper, one thing is clear: NGC 1277's silence isn't just in its stars or its black hole. It's written in the hush of its magnetic bones, a quiet so profound it speaks volumes about the universe's hidden rules. Buried in the gravitational whispers of NGC 1277, astronomers have caught the faintest hint of a cosmic dance, an anomaly in the motion of stars near the galaxy's core that suggests an unseen partner may be locked in orbit with the supermassive black hole. If confirmed, this phantom companion would be no ordinary object, but another black hole of staggering mass, circling its colossal sibling in a slow gravitational waltz. The implications ripple far beyond this single galaxy, threatening to upend our understanding of how galactic titans form, collide, and shape the universe around them. The evidence lies in the peculiar paths of stars skirting the galaxy's nucleus. While most orbit predictably around the primary black hole, a handful veer erratically, as if tugged by an invisible second force. Simulations reveal that only something with the gravitational heft of a second black hole, roughly 1 billion times the mass of our Sun, could explain these deviations. Even more telling, the disrupted stars cluster in a distinct pattern, tracing an arc that matches the predicted orbit of a binary partner. It's like watching leaves caught in a whirlpool, their swirling paths betraying hidden currents beneath the surface. But finding a black hole binary in NGC 1277 would be more than a curiosity, it'd be a cosmic first. While theory predicts such duos should form when galaxies merge, none have been definitively spotted in the local universe. The reason? Their orbits decay over billions of years, the black holes spiraling inward until they collide in a burst of gravitational waves. For one to persist today, it would need to be frozen mid-spiral, stalled by some mechanism we've yet to understand. That's exactly what NGC 1277 unique history might provide. Here's the twist: most binary black holes stall when they're light years apart, their gravitational influence too weak to clear out the surrounding stars and gas needed to continue their death spiral. But in NGC 1277, the primary black hole's bizarrely large mass and the galaxy's lack of gas could have created the perfect conditions for a standoff. The secondary black hole may have been trapped in a wide orbit, its progress halted because there's simply not enough material left in the galaxy to sap its momentum. The discovery would rewrite galactic evolution textbooks. Binary black holes are thought to be key drivers of galaxy growth, their mergers triggering bursts of star formation and reshaping entire galactic structures. If NGC 1277 harbors one frozen in time, it could explain why the galaxy stalled so early. The gravitational chaos of a near-miss merger might have ejected its gas and quenched star formation in one catastrophic blow. Even more intriguing, the duo's presence would suggest that NGC 1277 isn't the pristine relic we imagined, but the product of an ancient galactic collision. Its two black holes the last witnesses to that forgotten violence. Yet skepticism remains. Alternative explanations like a dense cluster of neutron stars or an asymmetry in the primary black hole's accretion disk could mimic the stellar motions. Confirmation hinges on catching the telltale flicker of material falling into the second black hole, or detecting the subtle gravitational waves such a pair should emit. Neither is easy with current technology, leaving astronomers in a tantalizing limbo between theory and proof. What's undeniable is the gravitational fingerprint this candidate leaves on its surroundings. Whether phantom or reality, its influence has already forced us to reconsider how black holes shape their galaxies, and how often the universe hides its most violent dances in plain sight. If NGC 1277's secret is real, it's not just a second black hole we've found, but a cosmic relic of a time when galaxies clashed in the dark, leaving behind echoes we're only now learning to hear. Among the aging stars of NGC 1277, a cosmic timekeeper ticks, an ancient planetary nebula that shouldn't exist, catalogued as Object 24. This glowing shell of gas pulses with the faded light of a dying star, its delicate filaments stretching across space like the petals of a celestial flower. Normally, such beauty would be unremarkable, except this nebula appears older than the galaxy hosting it. Dating methods place its formation at nearly 13 billion years, making it a relic from the universe's infancy. Yet NGC 1277 itself is thought to have formed slightly later. It's like finding a grandfather clock in a newborn's nursery, its hands frozen at a time before the room, or even the house existed. The paradox begins with planetary nebulae themselves. These luminous structures are the final breaths of sun-like stars, ejected when a dying star sheds its outer layers and illuminates them with ultraviolet radiation. The process typically takes billions of years. Stars must first live their full lifespans before undergoing this transformation. For a planetary nebula in NGC 1277 to predate its host galaxy, either the nebulous star formed impossibly early in cosmic history, or our understanding of galactic timelines is fundamentally flawed. One potential resolution lies in the way we measure age. The nebula's light carries a signature of extreme metal deficiency, suggesting its progenitor star belonged to the universe's very first generation, a population 3 star, theoretically massive and fleeting, burning out long before most galaxies took shape. If such a star somehow lingered longer than expected, or if its remnants were captured by NGC 1277 during a galactic collision, it could explain the age discrepancy. Imagine a tree seedling taking root in soil made from an even older tree's ashes. The materials predate the new growth, but the circumstances allowed their coexistence. But there's a catch. Population 3 stars were so massive they should have died in supernova, leaving no cores behind to form planetary nebulae. This has led some astronomers to propose an alternative, that the nebula's apparent age is an illusion caused by unique chemistry. Stars forming in NGC 1277 bizarre, metal-poor environment might have followed unconventional evolutionary paths, aging in ways that mimic ancient stellar populations. The nebula could then be a chemical doppelganger, mimicking antiquity without truly belonging to it. The most radical explanation involves time itself. If NGC 1277 resides in a region where the fabric of spacetime was warped by primordial gravitational waves, perhaps linked to the nearby cold spot, time dilation effects might make the nebula appear older from our perspective than it truly is. It's a cosmic version of the twin paradox, where relativity stretches one clock's ticks compared to another's. While speculative, this idea underscores how deeply entwined the nebula's riddle is with the galaxy's other anomalies. What makes this ancient nebula more than a chronological oddity is what it reveals about stellar life cycles in extreme environments. If it truly is a first-generation survivor, it could hold clues about the universe's earliest stars, objects we've never directly observed. If it's a chemical mimic, it forces us to reconsider how elements mix and evolve in secluded galactic corners. And if relativity plays a role, it hints that NGC 1277 might not just be a window into the past, but a funhouse mirror bending our view of time itself. Every photon from those glowing filaments carries not just light, but a challenge to rethink how we measure the ages of the cosmos's most stubborn relics. Tucked away in the archival glow of ancient gamma-ray detections, astronomers uncovered a spine-chilling coincidence. NGC 1277 sits directly along the projected path of one of the universe's most violent eruptions, a gamma-ray burst so powerful its afterglow outshone entire galaxies. Discovered in data from the early 2000s, this particular burst likely occurred when NGC 1277 was still young, its light traveling billions of years before reaching Earth. The odds of a galaxy this peculiar lying in the crosshairs of such an event are astronomically slim, raising an electrifying question. Did this cosmic cataclysm leave its fingerprints on the galaxy's evolution? Gamma-ray bursts are the universe's ultimate celestial artillery, capable of sterilizing entire galactic neighborhoods in seconds. When a massive star collapses into a black hole or neutron stars merge, they can unleash focused beams of radiation with the energy of a supernova concentrated into a needle-thin jet. Any planet or galaxy caught in the direct line of fire would experience an apocalypse of unimaginable scale. For NGC 1277, positioned at just the right angle, the effects could have been profound. The burst's high-energy photons would have ripped through its gas clouds like a scythe, ionizing atoms and stripping electrons with ruthless efficiency. In moments, the delicate balance required for star formation could have been obliterated, leaving behind the galactic fossil we see today. Yet the evidence is tantalizingly circumstantial. Unlike supernova, gamma-ray bursts leave no visible remnants, no expanding gas shells or pulsating neutron stars to mark their passage. Instead, researchers look for secondary clues, anomalies in the galaxy's chemical composition, gaps in its stellar populations, or even traces of radiation damage etched into the oldest surviving stars. Intriguingly, NGC 1277 metal-poor stars show unusual isotopic ratios, including a deficit of certain light elements like lithium, a pattern consistent with exposure to an intense radiation field. It's as if the stars themselves bear radiation scars, faint echoes of the devastation that swept through them long ago, but skeptics point to alternative explanations. The same elemental anomalies could stem from the galaxy's unique formation environment, or perhaps from a later burst of ultraviolet radiation from its own supermassive black hole. Even more puzzling is the timing. Gamma-ray bursts are fleeting, lasting only seconds to minutes. For one to influence an entire galaxy's destiny, NGC 1277 would have had to be almost impossibly close to the event, close enough for the burst's narrow beam to engulf it completely. The odds are vanishingly small, yet not zero. The most compelling argument for a connection lies in the galaxy's abrupt and premature aging. Most galaxies of NGC 1277 mass show signs of prolonged star formation, their gas reservoirs gradually depleted over eons. But this relic galaxy seems to have shut down all at once, as if its star-forming gas was violently expelled or rendered unusable. A nearby gamma-ray burst could have provided that very mechanism, its radiation pressure driving away loose gas, while its ultraviolet afterglow heated any remaining clouds too much to collapse into new stars. If proven, this link would rewrite our understanding of galactic mortality. Gamma-ray bursts are rare, but if even a handful of galaxies were sterilized by these events, it could explain why some corners of the universe appear unnaturally still. NGC 1277 might then represent a cosmic cautionary tale, a galaxy caught in the crossfire of a disaster so absolute it left behind only silence. The burst itself faded eons ago, but in this ancient galaxy's frozen state, we may finally be hearing its afterword. Among the many enigmas woven into NGC 1277 fabric, one stands out as a cosmic paradox, a filament of dark matter that appears to glow. This ethereal structure, catalogued as Object 26, defies the very definition of its kind. Dark matter, by nature, is invisible. It interacts with gravity but shuns light, leaving no trace for telescopes to capture. Yet here, draped across the galaxy's outskirts like a luminous veil, is something that shouldn't be, a dark matter thread pulsing with the faintest whisper of photons. It's as if the universe has painted an unseen force with strokes of ghostly radiance, leaving astronomers to wonder whether they've stumbled upon an illusion, an unknown interaction, or a crack in the foundations of physics itself. The first clue to this riddle lies in the light's peculiar qualities. Unlike the blazing emission, nebulae, or glittering star clusters that speckle most galaxies, this glow is achingly subtle, detectable only when stacking hours of observations from the most sensitive instruments. Its spectrum shows no recognizable atomic fingerprints, no hydrogen alpha lines, no forbidden oxygen transitions, just a smooth, featureless hum of energy. At first, researchers dismissed it as scattered starlight or an artifact of instrumental noise. But as data accumulated, the glow persisted, tracing the exact path predicted for one of NGC 1277 dark matter filaments, structures thought to channel unseen material between galaxies like cosmic rivers. One explanation leans on chaos. If the filament passes through a region littered with primordial gas clouds or the remnants of long-dead stars, collisions between particles could generate faint shocks, releasing energy as light. Picture two invisible ships sailing through fog. Even if you can't see the vessels, their wakes might stir the mist into visibility. Similarly, dark matter's gravitational tug could be compressing stray atoms in its path, heating them just enough to emit a feeble glow. Yet simulations struggle to reproduce the observed signal's uniformity. Shock-induced light tends to flicker and clump, not drape smoothly across megaparsecs of space. A more radical theory suggests we're witnessing dark matter's secret face. Most models assume it's inert, but what if certain particles can decay or interact weakly with photons under extreme conditions? Near NGC 1277 supermassive black hole, where gravitational fields warp spacetime into knots, dark matter might briefly leak energy into the visible spectrum. Alternatively, the filament could harbor a hypothetical dark force carrier particle that occasionally bridges the gap between the dark and light sectors of physics. These ideas remain speculative, but the glow's alignment with the galaxy's gravitational skeleton makes coincidence an increasingly implausible excuse. Then there's the unsettling possibility that we're misreading the cosmic map entirely. Gravitational lensing measurements confirm the filament's mass distribution matches the glow's contours. But what if another phenomenon, cosmic strings, magnetic fossils from the early universe, or even quantum fluctuations frozen in time, is masquerading as dark matter? NGC 1277 strangeness makes it a breeding ground for such ambiguities. Every known law of physics suggests dark matter shouldn't glow. Yet here, in this relic galaxy's shadow, something is shining where nothing should be. What elevates this mystery beyond academic curiosity is its potential to redefine reality's rules. If the filament's light stems from new physics, it could unlock dark matter's identity after decades of searching. If it's an illusion, it challenges our methods for mapping the invisible universe. And if it's neither, if this glow represents something entirely unforeseen, then NGC 1277 has once again proven itself a cosmic rebel, flaunting mysteries where we least expect them. In the end, the filament's faint light doesn't just illuminate the galaxy's hidden structure, it casts a glow on the limits of human knowledge itself. Drifting like a celestial ghost ship through the void near NGC 1277, Object 27 defies every expectation of cosmic order, a star cluster untethered to any galaxy, sailing the interstellar abyss alone. This nomadic swarm of stars, bound only to one another by gravity, moves with eerie independence as if it renounced galactic citizenship long ago. Most star clusters orbit galaxies like bees around a hive, trapped in eternal gravitational servitude. But this one, it's a cosmic fugitive charting its own course through the darkness. The cluster's very existence is a puzzle wrapped in starlight. Star clusters don't just form in isolation. They're born from the gas and dust of galaxies, nurtured in stellar nurseries before being flung into orbit. Yet this one shows no chemical ties to NGC 1277 or its neighbors. Its stars are metal-rich, suggesting a more modern origin than the galaxy's ancient population, but their motion betrays no gravitational handshake with any known structure. It's as if the cluster materialized out of nowhere or escaped so long ago that all trails leading back home have gone cold. One possibility is that NGC 1277 violent past spat this cluster out like a cosmic watermelon seed. Simulations show that during galactic collisions, tidal forces can fling entire star clusters into the void with enough velocity to escape forever. If NGC 1277 once cannibalized a smaller galaxy, the gravitational chaos might have catapulted this cluster clear of the wreckage, leaving it to wander indefinitely. The cluster's elongated shape supports this. Its stars stretch into a teardrop, as if still feeling the phantom pull of the galaxy that once held them. Yet there's a tantalizing alternative. Perhaps this cluster never belonged to any galaxy at all. In the early universe, dense pockets of gas might have collapsed directly into star clusters without ever forming a galactic core. These failed galaxies could have drifted through cosmic history like interstellar nomads, their stars burning quietly in the dark. If Object 27 is one such relic, it would rewrite our understanding of how structures form, proof that the universe sometimes builds stars without the scaffolding of galaxies. What awaits this unbound cluster is just as mysterious. Over eons, gravitational tugs from passing galaxies may pull it apart, scattering its stars like dandelion seeds. Or it could endure, drifting between galaxies for trillions of years, outliving every structure in the local universe. Some stars might even be stolen by other galaxies, their origins forever erased. But the most poetic fate, that it's captured, snatched from the void by a passing spiral, its stars assimilated into a new cosmic story. For now, this stellar vagabond remains a question mark. Is it a casualty of NGC 1277 turbulent youth, or a lone wanderer from the universe's dawn? Either way, its defiance of galactic gravity challenges our assumptions about where stars belong and who gets to call the cosmos home. Among the countless galaxies dotting the cosmic landscape, astronomers have noticed something spine-tingling about NGC 1277. Its precise orientation mirrors that of a far more distant galaxy, positioned almost perfectly behind it from our vantage point. This celestial doppelganger, located billions of light-years beyond NGC 1277, aligns with such eerie symmetry that their axes of rotation appear locked in an invisible dance. It's as if the universe placed a mirror in the depths of space, reflecting one galaxy's form onto another across unimaginable distances. The odds of such a perfect alignment happening by chance are astronomically slim, raising the hair-raising question: is this a meaningless cosmic coincidence, or could there be something deeper at play? The mirroring isn't just visual, it's dynamic. Both galaxies share nearly identical tilts relative to Earth, their spiral arms, or in NGC 1277 case, the ghostly remnants of what might once have been arms angled at the same peculiar degree. Even their apparent velocities match in a way that defies easy explanation, as if some unseen thread connects them across time and space. Skeptics argue it's a classic case of pareidolia, the human brain's tendency to find patterns where none exist, like seeing faces in clouds. After all, with trillions of galaxies in the observable universe, statistically, a few are bound to align by pure luck, but the precision of this particular pairing pushes even that logic to its limits. One tantalizing theory suggests the alignment might be a relic of the universe's large-scale structure. Galaxies aren't scattered randomly, they're woven into a vast cosmic web, with filaments of dark matter guiding their formation and motion. If both galaxies formed along the same filament, their spins could have been influenced by the flow of primordial matter in the early universe, imprinting a shared orientation that persists billions of years later. It's like two leaves caught in the same river current, turning in unison as the water swirls around them. Yet there's a wilder possibility that the alignment is no accident but a clue to something far stranger. Some theories of quantum gravity suggest that on the largest scales, the universe might exhibit symmetries we don't yet understand, echoes of a deeper order hidden in plain sight. Could this mirrored pair be a flicker of that hidden architecture, a cosmic fingerprint left by processes beyond our current physics? Or might gravitational lensing, warped by unseen mass, be playing tricks on us, distorting the background galaxy's appearance to match its foreground counterpart? The implications ripple beyond mere curiosity. If the alignment is meaningful, it could reshape how we map the universe's invisible scaffolding. If it's random, it forces us to confront just how profoundly chance can shape our perceptions of the cosmos. For now, the mirror galaxies remain a riddle, one that challenges not just what we see, but how we interpret the stories written in the stars. Every observation tightens the mystery, leaving us to wonder whether we're witnessing a fluke of geometry or the faint signature of a universe far more interconnected than we ever dreamed. One of the most radical explanations for NGC 1277 strangeness doesn't come from astrophysics at all. It emerges from the bizarre world of quantum mechanics. The quantum foam hypothesis, a speculative but fascinating idea, suggests that the galaxy's anomalies might not stem from dark matter, black holes, or cosmic collisions, but from the very fabric of spacetime itself. At unimaginably small scales, quantum fluctuations create a turbulent foam where space and time churn unpredictably, bubbling with virtual particles that wink in and out of existence. Most physicists assume these fluctuations average out on larger scales, vanishing into cosmic insignificance. But what if, in rare regions like NGC 1277, they don't? Proponents of this fringe theory argue that quantum foam could manifest macroscopically under extreme gravitational conditions, precisely the kind found near the galaxy's supermassive black hole. These fluctuations might subtly alter the behavior of light and matter, creating the illusion of missing dark matter or distorting star motions in ways that mimic unseen mass. The galaxy's frozen magnetic field, its eerily smooth structure, even its strangely quiet black hole, all could be side effects of spacetime itself behaving unusually, like a calm pond whose surface hides violent currents beneath. Critics counter that the math doesn't hold. Quantum effects typically cancel out at scales larger than a proton, making galaxy-spanning anomalies statistically implausible. Yet intriguingly, some modified gravity models, alternatives to dark matter, incorporate quantum-like behavior on cosmic scales, suggesting the line between quantum mechanics and gravity might blur in ways we don't yet grasp. NGC 1277 location near the cold spot adds fuel to the fire. If that cosmic anomaly stems from primordial spacetime defects, it's not impossible that quantum weirdness could linger there like echoes in a canyon. The biggest hurdle is testability. Quantum foam's hypothetical signatures, subtle variations in the speed of light, anomalous energy dissipation, are drowned out by cosmic noise with current instruments. Still, the hypothesis forces us to confront an uncomfortable truth. Our understanding of physics is stitched together from incomplete theories. General relativity rules the cosmos, quantum mechanics governs the tiny, and the two resist unification. NGC 1277, in all its defiance, might be the place where that rift becomes visible, not as a mathematical abstraction, but as a galaxy that plays by rules we're only beginning to imagine. Whether a fringe idea or a glimpse of deeper physics, the quantum foam hypothesis reminds us that the universe's greatest mysteries often lie not in the objects we see, but in the invisible frameworks holding them together. And if NGC 1277 truly is a cosmic rebel, it might be because spacetime itself rebels there, whispering secrets from the quantum void. Of all the wild theories surrounding NGC 1277's bizarre properties, none pushes the boundaries of physics quite like the cosmic string hypothesis, the idea that this galaxy might be entangled with a tear in the very fabric of spacetime. Cosmic strings are hypothetical relics from the universe's birth, when the cosmos underwent a violent phase transition moments after the Big Bang. Like cracks forming in ice as water freezes, these defects would be unimaginably thin but unimaginably dense. thinner than a proton yet stretching across billions of light-years, carrying the mass of entire galaxies compressed into ribbons of pure spacetime curvature. If one exists near NGC 1277, it could explain nearly everything anomalous about this galaxy, from its missing dark matter to its frozen magnetic field, by rewriting the rules of gravity locally. The first tantalizing clue comes from the galaxy's peculiar motion. Unlike its neighbors, NGC 1277 drifts through space with an odd, almost purposeful trajectory, as if tugged by something invisible. Cosmic strings would warp spacetime around them, creating gravitational wakes that could subtly deflect passing galaxies without the need for dark matter. Even more telling is the galaxy's uncanny alignment with the cold spot in the cosmic microwave background, a region some theorists argue could mark the intersection of a cosmic string with our observable universe. The cold spot's bizarre temperature drop matches simulations of how strings might redistribute cosmic radiation, leaving behind a faint scar in the oldest light we can see. But the most dramatic evidence lies in NGC 1277 star streams. These filaments of stars, stretched by tidal forces, curve in ways that defy conventional gravity. A cosmic string's unique spacetime distortion would shear matter passing near it, slicing through star clusters like a knife through smoke, leaving behind precisely the kind of jagged, asymmetrical debris we observe. The string's immense tension could also suppress star formation by preventing gas clouds from collapsing, potentially explaining why NGC 1277 stellar population appears frozen in time. It's as if the galaxy has been sutured into a pocket of altered physics, its evolution stunted by the universe's own scars. Skeptics counter that cosmic strings remain purely theoretical. No direct detection has ever been made. Yet NGC 1277's stubborn refusal to conform to standard models keeps the hypothesis alive. If a string does thread through this region, it would revolutionize our understanding of cosmic structure. These spacetime defects could act as cosmic seeds, guiding the formation of galaxies along their lengths like beads on a string. They might even explain oddities in other parts of the universe, from inexplicable gravitational lenses to mysterious voids where galaxies seem to avoid clustering. The implications stretch beyond astronomy into quantum gravity itself. Cosmic strings are predicted by certain unified field theories, including some versions of string theory. Finding one would bridge the chasm between particle physics and cosmology, offering a tangible link between the quantum realm and the large-scale universe. For now, NGC 1277 mysteries stand as both a challenge and an invitation to imagine a cosmos where the fabric of reality isn't just warped, but stitched together by flaws we're only beginning to conceive. Whether a cosmic string lurks here or not, the galaxy's defiance of expectations proves one thing: sometimes the universe's most profound truths hide in its cracks. NGC 1277 isn't just a galaxy, it's a cosmic revolt against the rulebook. From its monstrous, oversized black hole to its missing dark matter, from the rogue stars fleeing its grasp to the ghostly filaments of glowing dark matter, every discovery here feels like the universe is daring us to rethink what we know. This ancient relic has defied expectations at every turn. A galaxy that stopped forming stars billions of years ago yet harbors a cluster of inexplicably young blue stars, a gravitational footprint that hints at invisible companions, and a magnetic field frozen in time like a snapshot from the early cosmos. Even the quietest features, the vanished gas cloud, the backward spinning disk, the eerily aligned mirror galaxy, whisper of processes we've barely begun to unravel. What binds these 30 anomalies together isn't just their strangeness, but what they reveal about the gaps in our cosmic knowledge. NGC 1277 forces us to confront uncomfortable questions. Are we missing entire chapters of galactic evolution? Could dark matter behave differently in extreme environments? Is this galaxy a fluke or a signpost to something universal we've overlooked? Each mystery peels back another layer, proving that even the most well-tested theories are provisional, waiting to be appended by the next observation. The future of astronomy lies in galaxies like this one. With next-generation telescopes like the James Webb and the upcoming extremely large telescope, we'll peer deeper into NGC 1277 secrets, searching for clues in the faintest starlight and the quietest radio whispers. Every answer will likely birth new questions, and that's the thrill of exploration. The universe isn't just stranger than we imagine, it's stranger than we can imagine, and NGC 1277 is our reminder. So what do you think lies at the heart of these mysteries? A cosmic string, a hidden black hole binary, or something even wilder? Drop your theories in the comments. We're all cosmic detectives here. And if you're hungry for more mind-bending space stories, hit subscribe and join us as we keep unraveling the universe's greatest puzzles, one galaxy at a time. The cosmos is vast, but curiosity, that's infinite.